Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture, I am going to explain Umpolung. It is also called dipole inversion. Now see, carbonyl group is polar. Oxygen is more electronegative. So, this bond will break in this direction. Electron density will be shifted in this direction. Therefore, oxygen is having partial negative charge and this carbon is having partial positive charge. Since it is having partial positive charge, therefore it is electrophilic, means it is electron loving species. In Umpolung, the electrophilic carbon of a carbonyl group is transformed into a nucleophilic carbon. Now we have to see the definition of Umpolung. The inversion of the normal polarization of a functional group is called Umpolung. So, Umpolung is a process which temporarily reverses the polarity of functional group in organic chemistry. Now suppose benzaldehyde is reacting with benzyl bromide to form this compound C6H5CO CH2. Now see here what is the polarity of this covalent bond. Since Br is more electronegative than carbon, therefore this is having delta minus charge and this is having delta plus charge. So here this bond will break in this direction and you need this anion C6H5CO minus. This anion which can react with this to form this carbon-carbon bond. To make this carbon-carbon bond, since it is having partial positive charge, so here you should have anion. But this benzoyl, this is benzoyl anion. Benzoyl anion is very unstable, very unstable. So it's difficult to generate this anion in the reaction medium. So what you can do to carry out this transformation, you can generate one benzoyl anion equivalent. Benzoyl anion equivalent. And you can carry out this synthesis. With example, I am explaining this thing. And remember, this benzoyl anion equivalent, which one I will show you later, is stable. So you can generate this one. So to carry out this synthesis using Umpolung method, what you can do? First take this compound, this is propane 1,3-dithiol. This is one position, this is 2, this is 3. At 1 and 3, thiol group is there. Treat this with benzaldehyde C6H5CHO in presence of HCl. So this is dithiol, this is benzaldehyde in presence of acid. What will happen? Removal of this H and this oxygen will take place, means removal of water will give this compound. It is called 1,3-dithiene. So like this way we are protecting this aldehyde functional group. Now see, this hydrogen is very acidic because here benzene ring is there and here two sulfur are attached and sulfurs are electron withdrawing. It is electronegative. So this hydrogen will be acidic if you treat it with butyl lithium, strong base, in presence of tetrahydrofuran solvent at low temperature. This acidic proton will be removed and here you will get, this is your benzoyl anion equivalent, 1,3-dithion anion. Because see, from here removal of this H plus and formation of benzoyl anion is very difficult, but from this compound removal of this H plus is easier and we are getting this anion and it is serving the purpose of this anion. So it is benzoyl anion equivalent. Now if we treat this with C6H5CH2Br, then this anion and this bond will break. So this cation will make carbon-carbon bond. So here we are getting this carbon-carbon bond. Here CH2C6H5 and here C6H5. And if you treat it, if you do acid hydrolysis in presence of mercuric ion, so hydrolysis of this will take place and we will get back the ketone. So here we are getting C6H5. From here we are getting the original ketone, that ketone we are getting ketone, and here we are getting CH2C6H5. So this is serving the purpose of C6H5CO and we can do the synthesis using dipole inversion. In benzoin condensation also Umpolung method is used. In this video till this, if you like, please subscribe. Thank you for watching.